Hello everyone and welcome to the channel D for Developer. Today we'll try to understand the term microservice. If you are a software developer and working for enterprise applications, you must be hearing this term quite a lot these days, either in some projects or from your colleagues. So let's try to understand what is it actually. So microservice is an application architecture pattern of modern software development. It's actually a progression of the service-oriented architecture. Now, these are some high-level terms. What does it actually mean? So if we want to understand microservice, we can just refer this as an architecture pattern. So it's an approach of modern software development. Previously, we used to work with service-oriented architecture for our development work, but now it's microservice. So it's just an architectural pattern. Now let's go into a bit of more detail. In microservices, large applications are built as a collection of small functional services. So we have got a larger application and we dissect it, we convert it into a number of smaller services. So this is what we do in this approach. So that particular application is now made up of several small functional units, small functional services. These functional services are independently deployable, scalable, serves specific business goals, and communicates with each other mainly via REST APIs. Now let's try to understand this particular line because each term over here, uh, each term over here adds up to the making of a microservice. So let's try to understand each term. So first of all, it's independently deployable. Now you have got a larger application converted into smaller functional services. Now these particular services are independently deployable. So that generally means one particular service. Suppose there are two services, one and two. So when you are trying to deploy the service one, it is completely independent of service two. So there won't be any effect on the second service. So that is what we mean by independently deployable. Now it's independently scalable as per the traffic usage, as per the number of users hitting your service, one particular service. You can scale it up you can scale that particular service without affecting any other services. Okay, so it's independently scalable. Okay, now each particular functional service is going to serve specific business goals. So when we are trying to uh, follow this microservices approach, we need to make sure that whatever smaller services functional units that we have is contributing to a specific business goal. So it's kind of business oriented service. Okay, and communicates with each other mainly via REST API. So now you have got multiple services within your application, and now you want to communicate between those services because without communicating between the services, there won't be any exchange of information. So how do you communicate between those smaller services? That is done mainly via REST APIs. Now REST APIs is totally different and a larger concept to understand. So that will be covering it in another video. But for now, let's stick to the microservices. These services can also be implemented using different programming languages, have their own dedicated database. Now, this is a very important point to remember. Every microservice is going to have its own dedicated database. Okay, and it doesn't matter in which language you're trying to follow this pattern, follow this approach of development. Okay, because this microservices approach can be implemented using different programming languages. Now this I have heard from a lot of people, even from my colleagues, that microservice is a technology. Now this is referred to as a technology by many people, but that's not ideally correct. Okay, so I just wanted everyone to understand that this is not a technology and get this clarified for once and all. So, is microservices a technology? No, not at all. A microservice is not a technology in any form. It's just an architecture, a modern way of developing modern applications. That's it. So it's an architecture, it's an approach, it's a way of developing modern applications. So this is a very basic misconception that many have got. So by now I hope we have understood the term microservices. What does it actually mean? Now let's try to understand few characteristics and rules for a microservice. So what are the things or what are the characteristics that makes one particular service as a microservice? When can we say that this particular service is a microservice? So let's try to understand those particular characteristics. Remember guys, each and every line here is very important. So make sure you understand every bit of it. And I'll try to explain every line as we move ahead. So first one, it's always business oriented. Every microservices serve a specific business purpose. So when you're following this microservices approach, you have got a number of smaller functional services. Now, how do you divide these smaller functional services? On what basis? It's based on business requirements. So you develop one particular smaller service based on one particular business requirement. So each service over here is business oriented. It focuses on a specific business purpose. Now, microservice focuses on smaller pieces of service. There are no rules on how small a service must be, but making them too small can cause latency. So there is no rule like when you are developing a service, when you are dividing a larger application into smaller units, there is no rule that there should be this size of the service or uh, a specific service should be maintained of this particular size. So there is no hard and fast rule for that. So a microservice needs to be treated like an application or a product. I think it's pretty much clear. So it's like an application or a product. It should have its own source code management repository and its own delivery pipeline for builds and deployment. So this line has got two things. Now, source code repository and delivery pipeline. Generally, when we follow this microservices approach, source code management repository, we use GitHub for that. So it's nothing but when you have, I'll give a brief about this. When you have written your code and you want to store it somewhere, so where do you put it? Into a repository. Okay, so that particular source code repository, generally in microservices approach, we use Git. When we used to work with service oriented architecture, we generally used to use SVN, also called a subversion, as our source code repository. But now it's different. Okay, now let's get to the second part of it, and its own delivery pipeline for builds and deployment. In microservices approach, we generally use Jenkins for delivery pipelines. So it makes our build and deployment part easy. Microservices powered applications provide lightweight communication mechanism through the use of REST APIs. So now you have got smaller functional units. So there must be some exchange of information between the services whenever you need it. So how do you communicate between these two services? That is done mainly via the REST APIs, which is very lightweight. Now, REST APIs, as I already said, I'll be covering it in another video as it requires a huge amount of time because it's a larger concept. And if we want to understand it thoroughly, let's put that aside for now and we'll be covering it in a later video. Now, microservices should have independent storage, should be independently changeable, should be independently deployable, should support distributed transactions. Now, this particular line, as if you break it into fragments, we need to understand each and every term. So this is independent. This should have independent storage. So each microservice will be stored independently. It should be independently changeable. Now, what does it mean? Now, suppose you have got two different services built and you want to update one particular service. So we need to make sure that updation of one particular service does not affect the other service. So each services are not interdependent on each other. Okay. Now it should be independently deployable. Okay. So when you are updating one particular service and you want to deploy it, we must make sure that this deployment process of one particular service does not affect the other running service in any form. So it should be independently deployable. Okay, now let's get to the main components of a microservice architecture. So this microservice is an approach. So what are the components? What is a microservice generally composed of? So let's try to get to that. So these are the components of a microservice architecture: containers, clustering and orchestration, cloud infrastructure, API gateway, enterprise service bus, service delivery. For now, I've just mentioned these components so that at least you're aware that microservices as a whole is made up of these components. But we'll be covering each and every component in detail in separate videos.